Alright guys, this is your video lesson on space technology. So we have spent a whole lot of time talking about all these objects that are in outer space, and we are going to start talking about the technology we use to learn about those objects that are in outer space. Alright, so the first thing I want you to do is I want you to pause the video and I want you to write and answer these in your notes. And I'm going to discuss it just a little bit before I move on, but I do want you to go ahead and pause the video and I want you to answer these for me, okay? I want to know, number one, it says, have you ever come in contact with space technology? And I do want you to explain that one a little bit. So if you have come in contact with it, I want you to tell me where. All right. And number two, it says, list some pieces of space technology that you already know about. So if you know about anything that we use to look at outer space or anything that's in outer space that we put out there, anything that we've created to learn about outer space, I want you to tell me a little bit about it right here. Now, you don't have to tell me everything, but just give me one or two things if you already know something about space technology. So I want you to go ahead and pause the video and you can write that. You can type it in Google Docs, however you take your notes. All right. Now that you've had a chance to kind of answer these on your own. Number one, I know that some of you are probably going to say no, that you haven't come in contact with space technology, like you've never seen it, you've never touched it, you never played with it, any of that kind of stuff. But my job today is going to be to prove you wrong. All right. So when we talk about space technology, a lot of times people talk about telescopes, or that's what comes to mind. They think about telescopes, they think about rocket ships, they think about the big astronaut suits and stuff like that. But a lot of times the stuff that is technology from NASA, technology that was created specifically for space travel, has made it into our day-to-day lives, and we don't really think about it. So some things that you might not have thought about will be duct tape and Velcro and powdered sports drinks. Those are all technologies that were created with space travel in mind, and even Capri Suns. Capri Suns were used. First time they were used was when they were trying to get liquids up into outer space for the astronauts to be able to drink, and that was an easy way for them to be able to drink something. They'd put it in the pouch, they'd give them a straw connected to it, and they'd be able to drink out of it. Now theirs can reseal and stuff like that. That way, there's no water droplets floating around in the spaceship or wherever they are, because that water can or any liquids could damage some of the technology. So there's a little bit different than the ones we use here on Earth all the time. But those are some things that were created specifically for space travel that just kind of are really useful even here on Earth. All right. Now, this second one. All right. So hopefully all of you said something about, I don't know, telescopes or a rocket ship or something like that, and you know what they are. You know that we are going to talk about different kinds of space technology, and those are things that we could talk about today. All right. So there are a lot of things that could be listed there, and I know that I'm giving you a really short list, and we don't get to talk about a ton of this stuff in class, but I am trying to touch on the basics of things that you'll need to know about. All right. So I am going to go ahead, I'm going to teach you about just the basic things, and then the last, I'm going to show you something really neat that kind of broadens your thought of what space technology is. All right. So the first kind of space technology we're going to talk about is telescopes. And there are four main categories of telescopes. So when we talk about them, it's not just a telescope. They can be very different from each other. All right. So the first kind of telescope is a refractor telescope. And if we think back to our waves unit, refractors or refract means to bend the light. So a refractor telescope is going to use lenses that are shaped like this right here, convex lenses, to bend and focus the light to create an image for us to see. All right. So this picture right here, talking about the convex lens, this is you looking at the side of a convex lens. You're not looking through it. You'll be looking at the edge of it. All right. And the reason I did it that way is so that you can see what I'm talking about. A convex lens is going to be thinner near its edges and thicker in the middle. So if you've ever held a magnifying glass or play with a magnifying glass, you know that it's thinner near the edges and really thick in the middle. And that's so that it bends the light and makes the image a little bit bigger for us so we're able to see it better. And that's what that refractor telescope uses to help us see. All right. The next kind of telescope is a reflector telescope. And again, if you think back to our waves unit, to reflect means for that light to bounce off of it, okay? So a reflector telescope is using mirrors to focus the light and make an image for us to see what's in outer space, all right? So those mirrors are not always going to be flat. Some of them can be shaped like these lenses. Some of them can be kind of rounded to make those images a little bit clearer to enlarge things for us. But we are talking about mirrors here, not lenses. Okay. So there are still a couple lenses in a reflector telescope because there's one in the eyepiece and sometimes there's one in between some of the mirrors. But if there's mirrors in the telescope, it is considered a reflector telescope. All right. The next kind of telescope is a radio telescope. Now, this one is very different from the first two kinds of telescopes. We aren't looking through this thing right here and seeing directly what's in outer space. A radio telescope it's connected to a computer, so it's using those radio waves that it collects from outer space in that big dish. The computer knows where it's hitting on this dish. Okay, so it's using that information to generate an image on the computer screen for us to see. Okay, so this isn't just like a plain old telescope that we can just kind of walk and look in the lens and see what's going on. Okay, so if you think back to our waves unit, we talked about how radio telescopes were really low energy, but they were big waves. That's why this is so huge. So it can collect all these radio waves, and it doesn't matter whether it's in the edge or in the middle, it'll still be able to collect it, and that's part of why it's so huge. Okay? Now, if you want a little bit more, instead of just looking at the trees and the building, if you want a little bit more of an idea of how big this is, this little line going up the side of the building is a staircase. Okay? So that steps to go all the way from the bottom up to the top so people can work on the telescope and fix things if they need to. So a person could walk up this little piece right here and they'd probably be about the size of my cursor, probably a little bit shorter. They'd be a really tall person if they were that tall, but they'd be about that size. Okay. And there's also something else really cool about radio telescopes. They can receive information in any kind of weather and day and night. So you don't have to necessarily have darkness to be able to see with that radio telescope because they're just looking at radio waves. They're not relying on light to be able to give us a picture. Okay? And now I know that this last kind of telescope is kind of vague, but this is how it's listed. So I'm using the same kind of vocabulary that they will expect you to know. So when we talk about the last category of telescopes, we say other telescopes. And the two most common kinds of telescopes, if we're not talking about those first three, would be infrared or X-ray telescopes. Okay, so these are similar to the radio telescope. Okay, so, well, the X-ray one is more similar than the infrared one. A lot of times both of these will use computers to generate a picture for us to look at, but the infrared telescope, sometimes that can just be overlaid over what you're looking at. So if you're kind of like if you have ever used augmented reality on your phone, if you've ever put your phone up to something and had like it shows you something floating around in front of you, that would be augmented reality. And sometimes they do that with the infrared telescopes. Okay. But a lot of times these will be connected to a computer and show us an image on the computer screen. And instead of you being able to just look through the telescope and see things with it, like what we talked about with the reflector and refractor telescopes. Okay. All right, now the next kind of space technology. We're done with the telescopes now. The next kind is a space probe. So if we talk about space probes, we got to talk about the Mars rovers. Okay, so a rover is a type of space probe. A rover specifically can move around the planet on its own. It doesn't just sit in one spot. So that's a common name for these types of space probes that can move around the planet. Okay, so depending on where we're sending them and what we want to learn about the planet, they'll have all kinds of tools on them. So they're not going to be one size fits all. They're going to have different kinds of tools on these space probes. So this right here is an actual image from the Mars rover. So that's one of the pictures that the rover took and sent back to NASA. So this is what the surface of Mars looks like. All right. This bottom picture down here is a computer generated image of the rover. The rover can't take a picture of itself like that because this is the camera up here. But this is just what that rover looks like on its own if we were to imagine what it would look like sitting on the surface of Mars. Okay? So the reason we use rovers is because it's a little bit easier and cheaper to send that technology to a planet. We're not worried about astronauts not surviving or anything like that. And it's a little bit easier for the rover to survive because it doesn't need food and water. It doesn't need a way to feed itself. What it uses, this big flat panel right here, it uses solar panels to power itself. So as long as it can see sun, as long as there's sunlight shining on it, it can continue to work. Okay? So it's really helpful to be able to just charge that machine up and then tell it to do something and let it go. Because if it was an astronaut or astronauts, more than one, sent to Mars, you'd have to send them food, you'd have to send them water. It'll be a lot more expensive because you would have to create a place for them to be able to survive because it takes a long time to get to Mars and a long time to get back. Okay? So I think that they're kind of trying to put somebody on Mars, but we're not there yet. Okay? So with the space probe, we learned a lot about Mars, but we still haven't sent a human being to Mars yet. All right, and the next type of technology we're going to talk about is satellites. Satellites orbit around Earth or another body to collect information about different objects in outer space. So, a lot of times when we talk about satellites, we get stuck on they're pointed at Earth, they're looking at Earth. We see satellite images for all this weather stuff. We use satellites for GPS to navigate and tell us where we are. When we talk about satellites, it's not just around Earth. We sent a satellite named Cassini to orbit around Saturn and tell us all about Saturn. So there are other satellites that are going to go look at other objects in outer space. But for the most part, when we talk about satellites or when we've sent out a satellite, it's been satellites that are orbiting around Earth. Okay? And they give us a ton of information. They help us out all the time. So there's a lot of stuff that is really helpful for us, or a lot of information that's really helpful for us that comes from satellites. All right. And the next piece of technology, this one's kind of interesting. It's called a spectroscope, and it looks at all the light coming from distant objects in outer space, and it'll split it into the different bands of light. So when we talk about the white light has all the colors in it. It goes into the prism, and it's split into the rainbow color. So it takes that energy and divides it up based on its energy level. Remember, he said that red had really low energy, and by the time you get over here to violet, it's got a really high energy type of wave. Okay? So spectroscopes look at, well, they're mostly useful for stars, but they can look at other objects as well. But they're going to use that light from stars, and they'll split it up into the different colors, and we're able to tell what kind of elements are in that star based on the color. So lithium burns red. We know that if it's shining off red light, it's going to have some lithium in it. Okay? So when we talk about that as far as like different kinds of elements in different stars, we're using a spectroscope to figure that out. All right? Now, the last type of technology we're going to talk about, and this one is the most fun in my opinion anyways, we talk about space observatories. These are big, huge, well, not always. Well, yeah, they're pretty big. So these are huge satellites, basically, that are sent into outer space to orbit around some object. Now, the most famous one and the one that's given us the most valuable information is the Hubble telescope. Now, it's not just a telescope, but that's one of the main things that's on this space observatory that makes it really useful for us. Okay? So, Hubble was groundbreaking when they launched it. It was one of the first times we were able to see really clear pictures like this one on the top of the slide. Really clear pictures of objects that were far away from us on Earth. Okay? So Hubble was able to take this picture and send it back to us and give us some really cool information about outer space. All right? Now, space observatories are deliberately pointed away from Earth. Now, there's some that we can send to other places, but for the most part, they're here. They're orbiting us, but they are pointed away from us to look at other objects. All right? So, we're going to talk a little bit more about Hubble specifically, So if you click on this link right here, it'll take you to the Hubble telescope page. So it's going to have all these different pictures from the Hubble telescope that it was able to take and send back to us. All right. Here's one of Jupiter. You can see the red spot. And before we launched Hubble, before we were able to get these pictures, it was really, really hard for us to see this much detail of these objects in outer space. All right. So there's Saturn with its rings, and these are actual photographs. Now, some of them will be what would be like an infrared image instead of just a picture like we would take with a camera. And some of them are people that have worked on Hubble or gone to the International Space Station or done something. That's a picture of Hubble itself. It's probably taken by something else. But a lot of these are pictures from Hubble, and some of them are pieces that are like explaining what you're looking at. But these are all actual photographs from Hubble, and this one is one of my favorites. These are not stars, these are actually galaxies. So we're able to actually see a picture of all these galaxies out there in our universe and see how small we are comparatively and see how much else there is. There's a big, huge universe all around us. So Hubble is able to give us a new perspective on all the stuff that's around us in outer space. Now, if you want to, you can click on these pictures. Yeah, there you go. If you click on it and open it, this little button right here will let you download it, and you can use it on your Chromebook as like a background or whatever, or you can download it on your phone and use it as background on your phone. These are open source pictures. You could use them however. Okay? All right, so there's one more thing I want to show you, and this is kind of the really fun part of the lesson. Okay? All right, so this video right here, when we talked about, at the beginning class, we talked about whether anyone had come in contact with space technology ever. I know a lot of you are going to say no, but I do want you to stop and think about things that we wouldn't necessarily know are technically space technology. So I am going to watch this video with y'all, and we'll talk a little bit about this, and we'll actually use this information for a later lesson. Okay?
If you were born in the US after the mid-1990s, you most likely ingested a spin-off of NASA technology. Surprised? NASA spin-offs are everywhere. Ready? Let's see how many of these you've heard of before. Problem. Say you're an astronaut working outside the ISS using a wrench for hours at a time while wearing a bulky spacesuit. What do you do when your hand inevitably gets tired and you start losing grip strength? NASA's answer? How about not getting tired in the first place? NASA has developed a prototype robo-glove that actually amplifies the human grip. They modeled it on the robotic hand of something else pretty cool, the robotic astronaut, or Robonaut, which has already been tested on the ISS. Anyway, the RoboGlove tries to improve dexterity and reduce hand fatigue and repetitive motion stress for astronauts working on equipment during spacewalks. Next problem. The space station orbits Earth so fast that each new sunrise happens every 90 minutes. Not the best for your circadian rhythms, so how do astronauts get regular sleep? Alright, you know how driving a baby around in a car helps put it to sleep? Well, NASA funded researchers at Stony Brook University to analyze that very phenomenon. They found that hitting the ear with just the right vibrations could sync up the electrical signals going to the brain from the auditory system and from the vestibular system in the inner ear, which regulates balance. They tested extensively on hamsters, which apparently have really similar vestibular systems to humans, and eventually they figured out how to induce either wakefulness or sleep. So what's a spin-off? A downloadable insomnia app called Sleep Genius that combines that vibration research with classical music. Another spin-off? Sleepy hamsters. Next problem. Say you want to do an interplanetary manned mission. Ideally, you'd want to make the spacecraft a self-contained, closed ecosystem that can produce its own oxygen, recycle its waste, and generate its own food in order to keep fuel costs down. So how do you do that? Well, back in the 80s, NASA experimented to see if microalgae could help. Think about it. Algae eat waste, make oxygen, and some can even make nutritional molecules. Now, after NASA's initial interest faded, some of the researchers kept the project going and realized that certain species of algae could synthesize a compound found in human breast milk called DHA, which turns out to be important for brain development in babies. Today, this microalgae derivative is in over 90% of the baby formula sold in the US, and nearly 2/3 of the baby formula sold worldwide. So, If you were born after the mid-1990s and went for the bottle over the boob, even once, you, my friend, drank NASA tech. Next up, you know those gantries on launch platforms? The ones that feed the rockets fuel and electricity through these fat umbilical cables? Okay, just before and during blastoff, the vibrations from a rocket engine are insane. So, how do you keep that gantry from shaking to pieces? And not just that, how do you get it to actually detach and fall away smoothly without swinging all over the place? Answer, with the best shock absorbers ever. And if you can dampen the vibrations from a firing rocket, how about dampening the vibrations from earthquakes? The same company that developed NASA's gantry shock absorbers modified the technology and installed it in buildings, in places that get lots of tremors like Tokyo and San Francisco. So that's right, the NASA spinoff in this case is earthquake-proof buildings. And so far, of the hundreds of buildings in which the dampeners have been installed, none have suffered even minor damage during a quake.
All right, guys. So I am going to pause this one really quickly because I do want to point this out. If you've ever been on a tour to the State House here in South Carolina, I don't know if they still do it or not, but if they take you down into the basement to walk you from one side to the other, this actually is installed in the State House in South Carolina. So these big shock absorbers are there. The State House is actually sitting on very close to a fault line. So the big earthquakes, I don't know if any of you heard about this, but one of the last major earthquakes we had in South Carolina did some damage to the State House. It did a ton of damage in Charleston, but it's still that same fault line that's running, and it actually runs all the way through Lancaster County. So that was why they decided to install that into the State House building. It was something we were able to do that's going to hopefully keep anything from happening that would kind of mess up our State House.
Next problem. A space shuttle takeoff. It feels like about 3 Gs for the astronauts on board. Now during takeoff, they're all seated, kind of on their backs. So what material do you make those seats out of that would be firm enough to give support, but also have enough give that it wouldn't apply weird pressure points? Memory foam sounds like a pretty good candidate, right? Like in Tempur-Pedic beds? Well, where do you think memory foam came from? You got it, NASA. Now a really big problem. Astronauts in microgravity lose bone density 10 times faster than people on Earth with osteoporosis do. Muscle loss is also a major problem. So, how do you keep astronauts from falling apart in orbit? Answer, a chair that exercises for them. NASA funded some university researchers to experiment with targeted high-frequency vibrations that trick bones into thinking they're carrying weight so they won't deteriorate. While testing the system, the designers realized the vibrations also cause muscles to contract without voluntary effort. It's kind of like those ab belts on late-night infomercials, except this thing actually works. Now, right now, it's just in the prototype phase being used for experimental physical therapy, but in 10 years, I'm going to be jacked. Here's a serious problem. Inside a spacesuit, a rise in core body temperature from overexertion could be incredibly dangerous since there's no easy way to get that heat out. So how do you monitor a person's core temperature when that person is inside a spacesuit floating in space? How about a pill that takes your temperature? That's right, ingestible thermometers. Literally a pill with sensors and transmitters that takes your temperature from the inside. Next problem. How can you get pilots to see other planes through fog? Yeah, pilots, remember, the A in NASA is aeronautics. Answer, infrared laser strobe lights connected to a video camera. See, fog is opaque to visible light, but somewhat transparent to infrared light. By timing the return time of the laser pulse echoes and using image rendering software, NASA-funded research has helped develop a kind of infrared sonar for fog. Now, you know what else is also transparent to infrared light? Smoke and fire. So I think you can see the spin-off coming. Goggles for firefighters that can see through walls of smoke and flame, which is super badass. Next problem. Say you want to grow plants in space for food and oxygen. Now, plants need water, which is a precious resource on the space station that you don't want to waste. So, how do you know when to water plants in space? With NASA funding, university researchers developed a sensor that monitors plant leaf thickness, sends a plant health update to a computer, and then triggers automatic irrigation if needed. The spin-off? No-brainer, put the system on farms. The tech is still quite a ways from commercial viability, but interestingly, the prototype systems being tested on farms now can send status updates over text message. That's right, text messaging plants. All pretty cool, right? If you want to learn more, NASA Spinoffs actually has its own YouTube channel, magazine, and Twitter account, all linked in the description. Let us know your favorite spinoff, or let us know any good ones we missed down in the comments.
All right, so far, hopefully, I've kind of convinced you that space technology is all around us. All right, so space technology is not just the rocket ships and the space suits and satellites and things like that. There are a lot of things that we don't think about. Well, we wouldn't think about every day how astronauts would have to survive. So, just like not being able to drink out of a regular cup, they have to drink out of bagged fluids, bagged water, whatever, kind of like those Capri Suns. So, they're having to drink differently than us. They have to eat differently than us. So, they have to be really careful about the kinds of foods that they eat. They can't take regular bread into outer space because those crumbs will break off and get into the electronics and can mess up the space shuttle. So they always eat tortillas when they go into outer space. Now, there's probably some other ways to eat things, but if they make a sandwich, they're going to use tortillas because they don't give off crumbs, they don't fall apart as easily. So that's an easy thing for them to package and send with them to create sandwiches with. All right? And when they've got things that they need to like set down on a table or something like that, they can't just set it down on a table because a lot of times gravity doesn't work well. They aren't experiencing the same kind of gravity, especially on the International Space Station. They're not able to experience gravity there because it's just not there. I mean, the gravity exists, that's what keeps them in orbit, but it's not the same kind of gravity we experience here on Earth. They're floating around and kind of hanging out in outer space. All right. So when they go to set things down, they've got to have Velcro to hold it down. Because if you weigh something down, it's still going to be light in outer space if there's not that much gravity holding it still. So they use Velcro for a lot of things because they don't want magnets floating around in the space station because the magnets can mess up the electronics in the spaceship too. So when we talk about space technology, we're not just talking about these big things that we normally would think about. There are a lot of small pieces that go into space technology. All right. And that's it. We will talk about this a little bit more, but that's it for this lesson.